Alright, so my portion of the linear regression that we are doing our concept map on this week is the absolute minimums, which pertains to trying to find the least amount of error when using gradient descent. So far, when we've been looking at the kind of graphs for gradient descent, we've done in class the, casual, or I should say simplified parabola, just normally. And we talked about how we'd find the derivatives, like this point, and we saw that it was a negative derivative or a negative slope downwards, so we'd want to move towards the right into this area to eventually reach this minimum, right? We'd go back and forth until we would reach a simple minimum right here, and this would be the minimum error on the y-axis. So that would be where we would want everything to be when our variables set up so that our minimized error would be here. Now, the problem with this is, what happens if our error graph was not just a simple parabola, the amount of error goes up this way, and there's one minimum. What happens if our graph looked more something like this, where there were multiple local minimums, some with much higher error values than others? Well, we'd be in a conundrum. It'd really matter where we started our point. If we started here, we'd eventually reach this actual absolute minimum, but say we started like somewhere up here, we'd reach this minimum right here, which is not nearly as effective or accurate as the one that's down here. So, without having to, be a graduate in mathematics, be a mathematician, because an overarching way to solve this actually has not been found, just a simple equation or anything. The simplest way to do it right now is to choose multiple points along your error graph, within the domain that works for whatever data set you're using. And using computers, obviously, just take from each point, take them all down, use gradient descent with the derivative and everything to find minimums, right? So you'd eventually come to all these minimums that I have circled, and you'd compare all of these minimums, and whatever one was the least would be the variables you would use to have the most accurate linear regression graph.